And then this down here.
What's the tube, the ducts?
What are they
Ureter.
called? Ureters, right. This is the ureter. And so you have all of those areas. This area here, like right at the end of the renal pyramids, those would be the minor calyxes.
Minor calyxes. Yeah.
Right, these would be the minor, and where they converge would be like a major calyx, you know, right here, but not really important to distinguish them, but they're just parts of the renal pelvis. So you can see here the collecting ducts are what, as I told you in lecture, these are kind of striated because of the collecting ducts. They run vertically down in through here. So let's go through the arterial supply. This would be...
That's the efferent.
No, we're not talking about the...
No, that is an artery.
That's the renal artery. We're not to the nephron yet. We're not to the nephron. This would be the renal artery. Before it even goes into this whole area is called what? That where it indents. Yeah, this is the pelvis, but the indentation that allows
The
hilum. Just like in the lungs, have a hilum where all the vessels come in. So this is the renal artery. Before it even goes into the hilum, it divides into the first branch. Does anyone remember what it is? Segmental. Segmental arteries. So these big ones would be segmental arteries. The segmentals divide into these. Does anyone have those yet? They're called interlobar arteries because really there's like 7 or 8 lobes in a kidney between the medullary pyramid. So these would be the interlobar arteries. You go renal artery, segmental artery, interlobar arteries. Then these that curve over. Arcuate, because they make an arc around the, so you could, that's how you can remember, they make an arc around the medulla. And then these cortical radiate, because they radiate in the cortex, right? So these final ones are called cortical radiate arteries. And then the veins that drain them go in the opposite direction, same names. So, but that's fine. So then these little white dots, what do you think they're supposed to be? Hint.
The
Bowman's capsules.
Yeah,
Those are all supposed to be the little Bowman's capsules. So you can see them bigger here, right? So inside the Bowman's capsule is what? That capillary bed is called. You started to say it. Glomerulus. That's what this whole thing is, the glomerulus right here. Or you can see it in there. But remember what I said, it's like a baseball in a glove. I mean, you have this capillary bed, which would be your fist, and this is, there's your glomerulus. Whoops, goes like that. So anyway, okay, so those are Bowman's capsules. Let's jump to this one, because I think we got everything on this one. So here's the Bowman's capsules. This is supposed to be the glomerulus, so you have off of this cortical radiate artery, you get the afferent arteriole that goes into the Bowman's capsule. And what would this area be called? This is all the renal tubule, proximal convoluted tubule, loop of Henle,
and
distal convoluted tubule, and then collecting duct. Right, good job. Collecting duct. And this is why there's striations in the medulla, because there are all these collecting ducts, because many, many nephrons feed into one collecting duct. So there'd be a ton of these going down. What else can we see here? We do. We have a kidney. Yes, they're right in there. They're right in there. So
Like
I'll get you some gloves and we can, do you have some gloves? Just get a dissecting tray. That would be great, Rihanna.
I just want to see what it looks like.
Yeah, I don't blame you. I would want to see too. So anyway, what else can we see on here? Oh, this is distinguishing the two kinds of nephrons. Do you remember? There's two categories of nephrons.
The one.
This is called cortical nephrons, because the bulk of it is in the cortex.
Cortical.
Right? It does, the loop of Henle does dip down into the medulla, but the bulk of it is in the cortex, so that's a cortical nephron. This one, yes, juxtamedullary, because remember, this is the border between the medulla and the cortex, so this is called the juxtamedullary, and it's got this really, really long loop of Henle.
It's minor, right?
Well, it's really all loops of Henle. Do you remember what I said? What's the function of that long loop?
Is to
Reabsorption and
of water.
It all has to do water
Dilution,
balance.
dilution,
It's
water
what
balance.
controls whether you have a very dilute
concentrate-
urine or a
concentrated
concentrated urine, because it's permeable to water on this side and then sodium chloride on that side. So they function to either concentrate the urine if you're very dehydrated, or get rid of extra water if you're overhydrated. So
I was wondering, what is this? What does it lay on? What is this? Is it
That-
tissue or is it like a connectivity?
It is.
it's
cortex.
it's
It's
the
just by itself?
cortex.
It's
Yeah,
just
it's
fluid
just
or-
this part. It's
Okay.
just the cortex around the outside. This is just showing you like a blow up of one little area. So the bulk of the nephrons are these cortical nephrons. I think they said 85% of them are like this. The bulk of them are in the cortex. Only 15% of them have these really long loops of Henle that go down into the medulla like that. So now if we go to this next one, the blown up picture, this is, it's showing you that juxtaglomerular complex up close and personal. So one of these is the afferent. Which one is afferent, Nellie? How do you know?
Because it's thick.
It's thicker,
It's
right?
thicker. You have
guys
big
listen.
diagonal.
You guys listen, because it really could be like, that.
That's wrong.
It's wrong because the afferent, the one coming in, has a bigger
bigger
diameter.
yeah.
This is the efferent, is smaller.
It's smaller. Yeah.
Right, so that's how you can tell the difference. So this whole thing, this capillary bed, is the glomerulus, right? This is all Bowman's capsule here.
Dr. D,
Yeah?
I'm not touching that stuff.
Oh, is it yucky?
Yeah, it's dirty, it's just water.
Oh, it's always like that because it's a preservative.
It's different than the heart. You can look at it.
I'll look at it. Anyway, so what we're showing you here too is two different cells. Why is this yellow like that versus
This
red?
is the
Special filtration.
nutrition. Yeah.
All of them would be covered.
All
All
of them
of them
should
would be covered.
Yeah.
But they're just doing it for illustration
It's- okay.
purposes. Here, the capillary bed has all these little pores. They're called fenestrations. Because remember, this is very permeable. It lets everything out into here. So these little dots they're showing you are the fenestrations in the capillaries. On this side, what they're showing is actually part of Bowman's capsule. Because Bowman's capsule has two layers. This would be the parietal layer that's more structural. The visceral layer sits right on top of that. Sits right on top of that capillary bed. And it's made up of specialized cells called podocytes. And the podocytes, the blue is the nucleus of the podocytes, and they send out feet. It's right, well, it's not in that picture. It's another one that looks, there it is. Those are the, whoops, I'm so sorry, Lenny. So those are the podocytes that they're showing you with those feet. And that's just what allows everything to dump into there. It's very, very permeable. The other thing this is showing you is part of the juxtaglomerular complex. This is showing you a little bit of that ascending limb of the loop of Henle, which we said comes in very close contact with Bowman's capsule. And it has specialized cells called macula densa cells. They're tall columnar cells, and what they do, does anyone remember from lecture what they do? They're chemoreceptors. Salt. They measure the sodium concentration. They're very sensitive to the sodium concentration, and if it gets too low, they send signals to do things to make the kidney save salt. If it gets too high, then they allow it to secrete salt. These are also specialized cells in the afferent arteriole. Do you remember what they're called?
produce renal?
Yes, yes.
Granular.
Granular cells. These are supposed to be the granular cells. They monitor their mechanoreceptors. What do they monitor? These guys do salt. These guys monitor
Water.
blood pressure.
Blood pressure. Oh.
Blood pressure. So remember that whole cascade of events. If your blood pressure drops, these guys make renin, and renin is an enzyme that starts this whole cascade. It's called the renin-angiotensin aldosterone system. But the ultimate effect is that is to tell your body to save salt and save water. And so water will build up that will increase your blood volume and in turn bring your pressure back up. So the kidney is your main homeostatic organ for blood pressure. So it makes sense that it would measure, it has its own built-in little receptor to measure blood pressure. And if blood pressure falls too low, it can act quickly to bring it back up again. So those are the granular cells, macula densa cells and granular cells. And I think that's it for this model. Did you guys get all that?
Yeah.
It helps, right, to go through it.